Hi! Welcome to Year 7 Mathematics. Now, in a special edition, the Sunday evening edition. It is nearly 10 o'clock. So obviously you guys are also doing mathematics at this hour. So let's get to it. Ratios. We're starting ratios. We're actually doing this from the Year 8 text, although of course we are in Year 7 tonight. So normally I start this ratios with a discussion on what sort of things might involve ratios, and we end up in a discussion about things like recipes and maps and sport and legal requirements. If you have childcare centres and places like that that have ratios of number of students to teachers, we have that at school actually as well. We're at the maximum in one of ours, 28 to 1. So anyway, we can't have that great discussion, so we're just going to move on from there. Sometimes then I talk about trying to estimate some numbers, see if we can estimate the number of boys to girls in the school, or teacher's age to your age. That's definitely something we don't want to discuss. So it's good you're not there. Now, ratios of hours you spend outside to hours you spend inside. There's all sorts of interesting things we can do with ratios, but instead we're going to jump straight into the content. Now I'm going to cover the core content first, what you need to know. Then I'll give you a couple of modest challenges. I have some much more challenging, scary looking stuff for later in the week ready for you. You will not be disappointed. But for today, I'm not going to make things too difficult, given you're all doing it from home, and I don't know if you're there pulling your hair out or anything. That's all right to pull your hair out at your age. It'll probably grow back, but still not the best look. So here we go, ratios. So when I write a ratio, if I was to... green pen's not a good idea, eh? I have working pens. I'm sure you're impressed to see that. So I'd write a ratio. I'm going to do a general form. Don't you love that? So some number here, some number there. And you've got this symbol in the middle. You know what the symbol's called? It's called a colon. If you Google that, you'll get something very different. Don't do that. And you get two numbers. Now, generally, like fractions, we like to keep our ratios simplified. One of the strange things you'll find is there's no units. So when you write a ratio, you've got to make sure they're essentially in the same units before you get rid of the units. Look, that's shown best by an example. Like, let's say I was making some cordial. Now I know that cordial containers are now made terribly simply, and they have little markers so you can tell how much cordial you're meant to combine with water. Not that you want to drink that stuff anyway, hideous stuff, way too much sugar. But getting back to our story here, if I was to combine, say, 20 ml of cordial to, say, 1 litre of water, what we'd first do to be able to actually make that a ratio is we'd make sure they're in the same units. So the easiest way here would be to have both of them in millilitres. 1 litre being 1,000 millilitres. From there, we can remove the units. 20 to 1,000. But as I said before, we needed to simplify. We need to be in the simplest form. The same as we do with fractions. We look at that and go, well, what's the biggest number that goes into both of them? In this case, it's 20. So I divide both sides by 20. And I'm going to get 1 to 50. Or I hope I do, because I wasn't prepared to do that example, and we don't want to have any errors in this video. So the important thing there is that, it wouldn't matter now what the units are. For each 1 millimetre of cordial, there'd be 50 millilitres of water. Or for every 1 litre of cordial, there'll be 50 litres of water. For every kilolitre of cordial, there'll be 50 kilolitres of water. The relationship doesn't change. The beauty of once you've got a ratio, you can actually put whatever units you want on it. So the important thing is our final ratio there, it doesn't have units on it. Ratios do not show units. So what's the other thing I had to point out? Compare quantities. Oh, notice I've used whole numbers. Ratios are written in whole numbers. You don't see fractions. You don't see decimal numbers. So whenever you do end up with fractions or decimals, you have to make it so it actually involves whole numbers. We can play with that a bit later, make that a bit more difficult if we want. Put a bit of a challenge out there. All right, so yeah, no fractions and decimals. All right, they're your main points about ratio. I'm going to magically make this disappear and we're going to review a couple of skills that you must know. Then we'll go on and do a few more challenging things. Welcome back. I even have a friend here. Got lots of company this Sunday night. It's quite an event here. Now, first skill you've got to be able to do is you've got to be able to write ratios. That's what we're doing. You've got to be able to write ratios. So we've done a survey of Year 7 students and we've found that 12 of them like Kahoots, 10 like quizzes, and I have no idea where they found these students, but apparently 4 of them like Microsoft Teams. Don't tell anyone. Now, first challenge, let's write a ratio of Kahoots to quizzes. So how many like Kahoots? 12. How many like quizzes? 10. But there's something naughty about that ratio. What is it? It can be simplified. So again, we think what's the biggest number that goes into both? It's 2. And we're going to write the ratio. That gives us 6:5. So for every 6 students that like Kahoots, there should be 5 students that like quizzes. Second example, write a ratio of Kahoots to Teams. So Kahoots was 12 and Teams was 4. Again, you should be able to look at those numbers and say, oh yeah, I can simplify that. So yeah, we're going to divide both sides by 4 because that's the biggest number that goes into both, and we get 3:1. So for every 3 students that like Kahoots, there's someone who likes Microsoft Teams. All right, so last one, write a ratio of Kahoots to quizzes to Teams. That's right, we can write ratios with more than 2 parts. Cool, so let's do that. Kahoots 12, quizzes 10, and 4 for Teams. Now, we can simplify the whole lot. There is a number that goes into all of them. Happens to be 2. So if I divide all of them by 2, we get a final ratio there of 6:5:2 in its simplified form. Hopefully you can still see that at the bottom of the video. Right, and I was thinking of this because I actually had the most awesome Kahoot ever for you in class on Monday, and looks like it's not happening. We'll just have to scrap that Kahoot idea entirely forever. Anyway, importantly, notice we can write these things, we can write ratios and we can simplify them. There's only one more skill we need to check over in core, and then we'll do some harder stuff of our choosing. All right, students, so the second core skill is being able to write and understand equivalent ratios. So let's say we've gone out into the world and I've discovered that for every 1 person who loves golf, there are 4 people who love soccer. I've picked this fairly randomly. If you happen to like either, that's fantastic. But let's generate numbers that mean the same thing. So if for every 1 person who likes golf, there'll be 4 that like soccer, tell me, if there were 2 people who like golf, how many would you expect to like soccer? Yes? I'm presuming you're probably saying 8. Now, the trick here is, well, it's the same as fractions, really. If I wrote 1/4, you know that's the same as 2/8, right? We just multiply the top and bottom by the same thing, and they're equivalent fractions. Well, ratios are exactly the same. As long as you multiply or divide them by the same numbers, you'll get an equivalent ratio. So we can go a lot further than that. So in this case, we multiplied by 2. What if we multiplied everything there by 3? For every 3 golf fans, I'd expect to see 12 soccer fans. I could multiply it by 10. I could say for every 10 golf fans, I expect to see 40 soccer fans. I could multiply it by 1,111 and say, well, for every 1,111 golf fans, I'd expect to see 4,444 soccer fans. Look, as long as you multiply by the same number, you do the same to the left and right side of the ratio, you're going to get an equivalent ratio. It's still in the same proportion. All right, so from there, just a moment, I am going to say, okay, you'll get these sort of questions. Need to be able to do this sort of thing. If I gave you, let's say we had 4 to 9, there we go, that's a weird kind of ratio. And it might then say, well, fill in the blank. And what am I going to make that? I'll make it 45. How could you work that out? I'm figuring most of you probably already could tell me. Alas, what would I have to multiply that 9 by to get 45? Well, I'd have to multiply by 5. So we do the same to the 4. Remember, we have to do the same to both parts. We have to multiply or divide by the same number. So if I'm multiplying by 5, the 9 gets multiplied by 5. Well, the 4's got to be multiplied by 5 as well. You'll get 20. So, I mean, let's say I had another ratio. Let's say I had 13 to 18 equals, I'll make it 65 to an unknown. Same deal. I can work out what I need to multiply by looking at the equivalent parts of the ratio. So 13 times what is 65? You could also phrase that as 65 divided by 13. It's 5. Oh, I didn't mean that to make this. Should I make that harder? I'll make that harder. Sorry, we'll make it harder. There we go. We'll change that to 78. So in that case, 13 times what's 78? It's 6. So we'd have to multiply by 6. And we have to do the same to the other side as well. Now this is where I'm checking if your brain's working. What's that times 6? So 20 times 600, 108? 108? Are we running with 108? Not sure? Please tell me that's right. Yeah, that's right. Okay, the main point is you've got to multiply by the same amount to get equivalent ratios. And that's quite important when you're mixing different quantities of things. And I'm going to put up a practical example that you can work through with that in a moment. So I'll be right back. And magically, here we are, back yet again, with extra pistachios. Now, so that's it for the core content. If you want to get practice at just the skills that you must know for this lesson, then please go to the Year 8 text, exercise 6A, and have a go at those questions. I'm now going to give a little bit of extra stuff. I'm going to point out, firstly, how easy it is to simplify a ratio using a calculator. Essentially, you use the fraction functionality. So I've written the most ridiculous ratio here, 1,599 to 2,940. The trick is you put it in your calculator as a fraction. So I'm going to go 1599 over 2940. And I'm going to see what it's going to get. Now wait for this. I have an object of sheer beauty to show you this evening. It's an FX JP900. This is the most impressive scientific calculator in the world. If you manage to find one more impressive, just scientific of course, that's your restriction, you will have my undying respect forever. Now, I've got that out of the way. Let's put it in our calculator. So I've got 1599, I'm entering in it as a fraction, over 2940, and there we go. It gives me 533 over 980 in the calculator. And all I've got to do then is write it back as a ratio. So it's the same as 533 to 980. So that's a useful trick if you've ever got a truly ridiculous ratio that you suspect can be simplified, but you're not quite sure. There's only one particular case you have to be careful with that. I might demonstrate it quickly. Let's say I had 143 to 13. If you put that in your calculator, 143 over 13, I believe it'll just give you 11, but I'll just check that. It gives us 11. Notice there's no longer a fraction. So how do you turn that back to being a ratio? Well, it just means that the second ratio has gone down to 1. It no longer exists. So your final ratio there will just be 13 to 1. The second one has gone down to 1. Anything divided by 1, it's not going to show as a fraction, is it? Because what's 5 divided by 1? Just 1. Okay, I might put up something else on another board after this if you want to do something a little bit harder. So hang on. Hello there. One of the places that you see ratios is two-stroke two-stroke whippersnipper fuel oil combinations, right? Essentially in two-stroke motors, an older type of motor, most of your cars are not. Most cars are four-stroke, what they're called. Most modern motors are four-stroke. But occasionally you come across these old two-stroke motors, and recently I came across one, not by my choice, but it happens to be in a whippersnipper for edging of grass and that sort of thing. And you don't just put normal fuel in a two-stroke mower, you put in this mix of petrol and oil. And yeah, you've got to make that mix up before you put it in where the petrol is, and you've got to make this mix, otherwise it'll destroy the motor. So here we go. Your challenge, should you choose to accept it, is, well, in the ratio 25 to 1, so 25 parts petrol to 1 part oil. It's not an unusual ratio to see in this area. Tell me, if I put in that much petrol, how much oil would I then have to put in, and how much mixture would I create in total? Same for that. I'm saying, well, 2.5 litres of petrol, how much oil, how much is the total batch? And down here I've gone, well, what if I've given you the amount of oil I'm putting in the batch? If I've given you the amount of oil, you should be able to work out the amount of petrol and the total quantity of the batch. The hardest one is this. These ones down the bottom here, where I've given you the total amount of the batch that's being created. If I wanted to create a 760 ml batch, tell me how much oil and how much petrol will I have to put in? That's harder than those ones. And I'll leave that challenge to you. Have fun. Well, Year 7, that's about it for today. I understand this isn't the hardest lesson, but I do want you to be able to confidently do it at home. If you find it all too easy, send me an email and I will then send you some really hard stuff, including some questions I haven't quite sorted out myself yet, mainly because of time, but also I reckon you'll find them nicely challenging. So that's all. Bye.